Welcome. Dear students, today we are going to study about Friedel Crafts Acylation reaction. In Friedel Crafts Acylation reaction, we will see its reaction and synthetic and applications. We will see hand to hand, that is we will see combined, and then we will go for mechanism. Friedel Crafts acylation is an example of electrophilic aromatic substitution reaction. To know what is electrophilic aromatic substitution reaction, kindly refer my video Electrophilic Aromatic Substitution Reaction in Benzene. Here we are going to discuss that in short, and then we will discuss the synthesis and little bit applications, and then we will go for mechanism. So what is electrophilic aromatic substitution reaction? It involves an electrophile. The electrophile has a positive charge over it, and because it has a positive charge over it, it approaches a benzene ring to snatch an electron pair from it. However, this electrophile is unable to do so because the 6 pi electron or the pi electron system is in constant dynamic motion in the benzene ring. So it is not able to snatch an electron pair from benzene ring. Instead, what it does is that it replaces one of the hydrogen. It replaces one of the hydrogen, and the hydrogen that dissociates, it goes with a base which is present in the reaction system. So this is what happens. So here the problem was started by an electrophile. It was initiated by an electrophile. The problem took place in an aromatic system, and the problem resulted in a substitution. So therefore benzene undergoes electrophilic aromatic substitution reaction. Okay, so Friedel Crafts acylation is an example of electrophilic aromatic substitution reaction. Let us see who is the electrophile in Friedel Crafts acylation. The electrophile in Friedel Crafts acylation is the RCO plus group. This is called as the acyl cation. This is an acyl group. This is an acyl cation. Now there are three sources of acyl cation. The first source is acid chloride. The second source is acetic anhydride. Okay, so acid chloride I will write like in this way, RCOCl, acid chloride. It can be acetic, it can be acid anhydride, right? And the third source of the acyl cation is an ester group. Okay, so these are three sources. One is the acid chloride, the second is acid anhydride, and the third is ester group. These three sources can be used, and you can get a this electrophile, that is a acyl cation. Okay, so the reaction, Friedel Crafts acylation reaction involves, you can use either 1, 2 or 3. Okay, so here I am using first one, that is acid chloride. You can use an acid chloride, react it with benzene in the presence of any Lewis acid catalyst. It can be FeCl3 or AlCl3. Here I am using AlCl3, and as we have studied that this is the electrophile, so you have to take this electrophile and replace any one of the hydrogen atoms of the 6 carbon atoms. So I am replacing this hydrogen atom, the hydrogen which was present here, and to this carbon I link the acyl group, and one hydrogen goes from here, it combines with chlorine, it becomes HCl. So here we go. So you can see it is an introduction. This Friedel Crafts acylation, the reaction is an introduction of acyl group at any of the positions of the benzene ring. Okay, so that is Friedel Crafts acylation. Now what have we made through this? What have we achieved through this reaction? We have achieved one product. The product is alkyl phenyl ketone. Alkyl phenyl ketone. So Friedel Crafts acylation is used in the preparation of alkyl phenyl ketone. Alkyl phenyl ketone. Okay. So that is its first application. This is its reaction. Okay. We understood the electrophile here. Acyl cation is the electrophile. There can be three sources of acyl cation: acid chloride, acetic anhydride, or ester. You can use any of these. React it with benzene group. In the presence of Lewis acid catalyst, you will get an alkyl phenyl ketone in which the alkyl cation or the alkyl group has been introduced to any of the position of the benzene ring. So you get the first product, that is alkyl phenyl ketone. So it's used exclusively for the preparation of alkyl phenyl ketone. Okay. Let's go for its second application. I'm rubbing all this. Okay. Just notice this alkyl phenyl ketone. Just notice this alkyl phenyl. I am going to rewrite that alkyl phenyl ketone here. Okay. What have we got? Alkyl phenyl ketone through Friedel Crafts acylation. Okay. What would I get if I am hydrogenating this? Let me do that. Let me hydrogenate it using H2 platinum. And what do I get? Yes, you are right. I get alkyl benzene. I get alkyl benzene. Students, do you remember which reaction was used for making alkyl benzene? For making yes, Friedel Crafts acylation. So usually we use Friedel Crafts acylation reaction to make alkyl benzene. It is also possible to make alkyl benzene through Friedel Crafts acylation. That is what we have seen. This is the Friedel Crafts acylation first product, methyl phenyl ketone, right? Oh, sorry, alkyl phenyl ketone. And if we are hydrogenating the first product of the Friedel Crafts acylation, we get alkyl benzene. So we can make alkyl benzene through Friedel Crafts acylation also. Which is the better method? That is the question I am saying. Let me say to you that Friedel Crafts acylation is the better method to make alkyl benzene. Why? Because in Friedel Crafts acylation, there are lot of drawbacks. Lot of drawbacks are there. Two of which are polyalkylation or polysubstitution, and the second drawback is skeletal rearrangement. So because of these two drawbacks, we don't get expected product. Take the case of skeletal rearrangement. We don't get the expected product because there is intramolecular rearrangement of carbocation. And in polyalkylation, we don't get the expected product in desired yield. So therefore, better than Friedel Crafts acylation is Friedel Crafts acylation in preparation of alkyl benzene. We give preference to this method only to make alkyl benzene, not to this method, because Friedel Crafts acylation has a lot of drawbacks. Dear students, if you want to know more about Friedel Crafts acylation, please refer my video Friedel Crafts acylation, its reaction mechanism and drawbacks. Let us now come back to other applications of our Friedel Crafts acylation. Let me rub the board. Do you remember the acid chloride that we used? This was the acid chloride that we used for Friedel Crafts acylation, right? Now this is the third application of Friedel Crafts acylation. Kindly concentrate. Okay. Now, if I am replacing this R with Cl, okay, this is carbonyl chloride. If I am replacing that R with Cl, what would I get? If I am making it react with benzene in presence of AlCl3, then what is the product that I get? Let me write it here. I get a product like this. What an awesome product did I get? This is benzoyl chloride, right? So therefore it can be used in preparation of aryl acid chlorides. Aryl acid chlorides. Here we have made benzoyl chloride. Okay. Shall I ask you another question? What would happen if I am going for hydrolysis? Okay. Then what product would I get? Yes, I will get a acid. So you can make aromatic acids. Here I have got a benzoic acid. So this is the third application of Friedel Crafts acylation. You can make aryl acid chlorides. Number fourth application is you can make aromatic carboxylic acids. So these are the third and fourth applications of Friedel Crafts acylation. Let us go for the fifth application. Now let me ask you a question. What would happen if I am replacing this Cl and I am putting an H in place of that, and I am reacting it with benzene in presence of AlCl3? What would I get? Right, very useful product. That would be benzaldehyde. Fine, that would be benzaldehyde. So that is the fifth application. You can make aromatic aldehydes. Aromatic aldehyde, here I have got benzaldehyde. So you can say that there are 5 applications of Friedel Crafts acylation. Number 1, you can make alkyl phenyl ketone. It is used exclusively for that preparation, for its preparation. Number 2, you can make alkyl benzene. You can also make alkyl benzenes using Friedel Crafts alkylation, but Friedel Crafts acylation is a better method. We have discussed the reason, and you can refer my video for more details. Friedel Crafts alkylation. Number 3, we have made benzoyl chloride, aromatic acid chlorides. We have made aromatic carboxylic acid, which is number 4, and number 5 we have made aromatic aldehydes. Okay, we have shown here how we have made benzaldehyde. Now dear students, let us go to the mechanism of Friedel Crafts acylation. We have discussed the reaction, and now we are going to discuss the mechanism. What is it? An example of electrophilic aromatic substitution reaction. And as you know, electrophilic aromatic substitution reaction consists of 3 steps. Step 1 is the birth of the problem maker. Who is the problem maker here? The electrophile. So the first step is the formation of electrophile. Formation of electrophile. What reactant is used here? Acid chloride, right? So I am using RCOCl. You can use acetic anhydride, or you can also use ester, and treat it with Lewis acid catalyst, AlCl3. Okay, you can use FeCl3 too here. Al has an empty d orbital. It accepts a pair of electron. Okay, so here is the pair of electron which it will accept. The Cl will go here, and what you get is the acyl cation, and you get AlCl4 minus. Now this is the Lewis acid. This is its conjugate base. Note the conjugate base. We will use this conjugate base in the third step. Okay, so that is step number 1. Let us go to step number 2. In step number 2, what do you think? The acyl cation will remain idle? Never. It will go and attack the benzene ring, right? So in step 2, we will see that attack and the formation of carbocation. So let us go for step 2. Formation of carbocation. Formation of carbocation. The acyl cation, the acyl group, it is written like this, and let me draw the benzene like this. This is the electrophile. It wants an electron pair. Suppose if it attacks this electron pair from this position, then what structure would I get? That I am going to write. This is the structure that I would get. These electron pairs are intact at its position. When this electron pair was given to acyl group, each bond is made up of 2 electrons. The carbon here didn't have any loss. Okay, its electron is still here. This electron was actually given to the acyl group. So the carbon which is at loss is this, right? Now to compensate the loss, this electron pair shifts here, and when it shifts here, this is also made up of 2 electrons. This carbon's electron is still here while this electron goes there. So the loss is with this carbon. So what structure will you get where the positive sign will come? Here, right? And this is the structure right now, right? To compensate the loss of electron here, this bond shifts here, jumps here, and when it jumps here, which carbon is at loss? Yes, this electron is still here while this electron goes here, so this carbon becomes at loss. So positive sign rests on that carbon atom. So like this we get a structure. This jumps here, fine. Now the overall structure for this carbocation is something like this. Here is the COR group, here it is H group, and here overall the positive sign is rotating inside the benzene molecule. So such a situation is very unstable and benzene wants to get rid of it as soon as possible by taking an electron pair back. So that is what would happen in the next step. Step number 3, abstraction of hydrogen. Abstraction of hydrogen. Step 3, abstraction of hydrogen. So I am going to draw the carbocation that I have left in step 2 here. This was the carbocation that I have left there. Everything is positive around it, and CORH. Do you remember that base, conjugate base formed in step 1? Yes, AlCl4 minus, right? Now what would happen? This carbocation is unstable. This electron pair goes back into the ring and H goes here. So you get a alkyl phenyl ketone, and the other thing that you get is HCl, and you get the catalyst back to AlCl3. So you get an alkyl phenyl ketone, you get the AlCl3 back, and that is how you make that is how alkyl phenyl ketone results. Dear students, that is all about Friedel Crafts acylation. If you do understand, if you do like the video, don't forget to subscribe. Thank you.